Unit 5, Learning Target Number 2, Recognize and Simplify Equivalent Ratios. In this lesson, we're going to talk about equivalent ratios. Equivalent ratios are just ratios that are equal to each other. Just equal to each other. And to give you a hint, you can think about fractions, because ratios and fractions are very similar. You can think about fractions and how you can have equivalent fractions. To look at this and to see this a little more clearly, let's take a look at a graph situation. We're going to graph this ratio that we have here. So first of all, Jason reads one page of his book every 2 minutes. How can we see that as a ratio? Well, if he reads one page every 2 minutes, then that is our ratio, 1 to 2. And if we want to graph that, we'll start up here with the 1. In every one page he reads, it takes him 2 minutes. For every one page he reads, it takes him 2 minutes. So, think with me, to figure out if he were to read 2 pages, how long would it take him? It took one page 2 minutes to be read. So, now he has 2 pages to read. How long will that take him? Well, we're doubling the number of pages, so it would seem like we would double the number of minutes it would take. So we'll say 2 over 4 here. 2 pages took 4 minutes. And let's think about it again. If it takes him 2 minutes to read every one page, then if he reads 3 pages, then it would take him about 3 times that amount of time, which would be 6. So 3/6. So we'll go over here to 3, and we'll say it takes him about 6 minutes. Here's the question I have. Can you predict the number of pages Jason will read in 4 minutes? The number of pages he will read in 4 minutes. Now let's look up here. In 4 minutes, we'll go all the way up here. If it takes him 2 minutes to read one page, it's going to take him 4 times that amount, so that'll be 8. And he'll read 4 pages in that amount of time. So 1, 2, 3, 4, 2, 4, 6, 8 minutes. Now, are all of these ratios the same? Are they all the same? Well, if you remember from fractions, yes, in fact, they are all the same. 1/2 is equal to 2/4 because we can divide this by 2 and divide this by 2, and we get 1/2. And the same thing with all the rest of these. If we divide 3 by 3, we get 1. 6 by 3, we get 2. And all of these are equivalent ratios. Now, if we take a look at this, this is kind of neat. If you take a look at this, this makes a line. This is a very special kind of graph. It makes a line straight along there. And that is what all proportional relationships look like. They have this kind of diagonal line that comes out of them. Let's take a look at this ratio right here, 6 over 9. How could we write this ratio differently? Based on what we know about fractions and what we learned on the last slide, how could we write this differently? Well, first we could find a number that goes into both of these. Does 2 go into both of these? No. What about 3? 3 does seem to go into both of these. So let's try dividing 6 by 3. And what do we get? We get 2. And if we divide 9 by 3, what do we get? We get 3. So we wind up with 2/3. These two ratios are equivalent to each other, and if we were to graph them, we would get a graph just like we got on the previous slide that looks like that. Now, in this case, we have 2 equivalent ratios just by simplifying these ratios. This is called simplifying, just like when we simplify fractions, because again, ratios and fractions are basically the same thing. Ratios simplify just like fractions. So let's take a second and simplify both of these ratios. In this case, we have 2/4. 2 can be divided by 2. Whoops, I lost my screen there. Let's try to pull that out again. 2/4 can be divided by 2 on the top and 2 on the bottom. So if we take 2/4 and divide it by 2 on the top and 2 on the bottom, what do we get? We get 2 divided by 2 is 1. 4 divided by 2 is 2. We get 1/2. So our answer is 1/2. Now, if we want to simplify this particular one, your first instinct might be, well, I need to convert that to a mixed number because 6 will go into 27, 4 times, and that'll leave 3/6 left over, and then I need to make that into 4 1/2. But ratios never simplify to mixed numbers. We don't do that. We never simplify ratios to mixed numbers. What we're going to do instead is try to find, again, a number that will go into both 27 and 26 and simplify it as it is. Well, I know that 3 goes into 27, so I'm going to divide 27 by 3. So I'm going to divide that by 3. That's going to give me 9. And I know that 6 is divided by 3, and it gives me 2. So I get a ratio of 9 to 2. 9/2 is my ratio once I have simplified it. And again, these are equal to each other. They've just been reduced like fractions. One more time, let's take a look at a graph of a ratio or a set of ratios. In this case, we're looking at a recipe, and in our recipe, for every one cup of chocolate chip cookies, of every chocolate chips, then for every 1 cup of those, we're going to have 2 cups of sugar. So we look at our graph. 1 cup means we'll have 2 cups of sugar. 1 cup of chocolate chips is 2 cups of sugar. 2 cups of chocolate chips is 4 cups of sugar. 3 cups of chocolate chips means we'll use 6 cups of sugar. 4 cups of chocolate chips means we'll use 8 cups of sugar. So what would it be if we were to use 5 cups of chocolate chips? It would be a lot of chocolate chip cookies. That's what that would be, which is fine with me. I like chocolate chip cookies. We go over here to the 5, and then we go up to the 10, just like it says right over here. For every 5 cups of chocolate chip cookies, of chocolate chips, we'll use 10 cups of sugar. So we'll go all the way to the top here, just like that. And once again, we can draw our little line to see how these are related to each other. A graph kind of helps us see this ratio relationship in a special way. Now, one thing I want to tell you, and you don't really need this at this exact moment, is that this will help us with equations. You remember, an equation is just any two things that we make equal to each other. We like to make them variables, right? So x is equal to 3, or y is equal to 2 plus 1. Over here we have a kind of equation. Now this equation has 2 variables in it. It has a y variable, and the y represents the amount of sugar, the number of cups of sugar. So this equation tells us that if we want to find out the number of cups of sugar we need for the recipe, then we need to look at x, which is the number of cups of chocolate chips. Take a look at x to find y. In this case, we know we're going to multiply 2 times x. We're going to take x and we're going to multiply by 2, which is exactly what we did. 1 times 2 is 2. 2 times 2 is 4, 3 times 2 is 6, and on down the road. So y is sugar, x is the number of cups of chocolate chips there, and we're going to multiply 2 times that to get the number of cups of sugar. And that's what this represents. Our equation y is equal to 2x gives us a plan of how to get y. Y is equal to 2 times whatever x is. This is x, and this is y.